Right, you are now on question number 2. It reads, express root 6 cos theta minus root 2 sin theta in the form r cos theta plus alpha, where r is greater than 0 and alpha lies between 0 and 90 degrees. Meaning to say that our alpha here in this case is going to be an acute angle. Right. So when you have an expression which starts with cos, we usually express it in r cos form. But for r cos, there is a sign change. If you have negative here, you put a positive inside the bracket. So what I'm trying to say is, you may come across a question whereby you have root 6 cos theta plus root 2 sin theta. To express this in r cos, it means since we have a plus in between, we are going to have a negative inside the bracket. I hope you are following. Like in this case, we have a negative in between the trig ratios. You put a plus. There is a sign change for r cos. But for r sin, there is no sign change. You take it as it is. Meaning to say, if you have root 2 sin theta plus root 2 cos theta, the fact that you have started with sine, you express it in r sin form. I hope you are following. But for sine, there is no sign change. If there is plus, the plus remains plus. For cos, the plus tends to negative. Right. So how do we find r? R is found by squaring root 6 and root 2. So you are saying root 6 squared plus root 2 squared. Something like this. What is root 6 squared? You get 6. What is root 2 squared? You get 2. So it means r is good as root 8 or 2 root 2. So we accept root 8 or 2 root 2. I hope you are following, class. Right. Then to find alpha, you say arctan of root 2, you ignore this negative sign, so you take root 2, you divide root 2 with root 6. I hope you are following. But when you are dealing with complex numbers, let's say you have root 6 minus root 2i, then you want to find the argument. You say arctan of minus root 2 divided by root 6, meaning to say for complex numbers, you take this root 2 with its negative. But for trig, to find alpha, you take root 2, but you ignore the negative sign in between. I hope you are following, class. Right. So, since the limits of alpha lies between 0 to 90 degrees, it means that your calculator must be in degree mode. So you make sure that your calculator is in DEG mode, right? Then second function, arctan, open bracket, root 2 divided by root 6. Then you get 30 degrees. So it means alpha is representing 30 degrees, of which 30 degrees lies between 0 and 90 degrees. I hope you are following, class. So the form is now found by substituting r and 90 degrees in the r cos, right? So on r, you put 2 root 2 or root 8. Then you write cos, open bracket, theta plus 30 degrees. Then you get yourself 2 marks for part A of the question. I hope you are following. Let us move on to part 2 of the question. Hence or otherwise, solve the equation root 6 cos theta minus root 2 sin theta is equals to 2. For 0 less than or equal to theta less than or equal to 360 degrees, 5 marks. Right, so we are given the equation root 6, right? Cos theta minus root 2 sin theta is equals to 2. They want you to solve this equation. The first thing to do is to substitute the left side with the form that you have obtained in part A. So you are going to say root 8 cos theta plus 30, which is good as 2 root 2 cos theta plus 30. You place it on the left side. Then equate this with the 2. I hope you are following class. Right. Then divide both sides by root 8. You get cos theta plus 30 is equals to 2 divided by square root of 8. Something like this. Then theta plus 30 degrees is equals to arc cos of 2 over root 8. To make this bracket the subject, you remove cos, but you write it as arc cos on the right side to get what we call the principal solution or the principal value. So you are saying theta plus 30 degrees is equals to, then you take your calculator, you punch second function, arc cos 2 divided by root 8. You get 45. So I'm going to write 45 degrees, representing my principal value. I hope you are following class. Right, so since we are dealing with cos, to find the complementary angles of 45, you say 360 minus PV to find the second one. Then the third one is obtained by saying 360 plus O. The third, the fourth, the fifth, you use the formula 360 plus O. But if you are dealing with the sign, here you write 180 minus PV, then you write 360 plus O. I hope you are following. Right. So be careful, because we need the complementary angles which lies in the given range. 0 less than or equal to theta less than or equal to 360. So bear this in mind. So we don't want solutions which are outside the defined region. Right. So the first angle is 45 degrees. I hope you are following. But for cos, right, if you get 45 degrees as your PV, you also need to make use of minus 45. Right? Let us proceed. 360 minus 45, what do you get? 360 less 45, you get 315. This is the second angle. Then 360 plus 45. 360 plus 45, you get 405. But if you less 405 with 30 degrees, you get 375. So this is outside the range. I hope you are following. So we are going to have two solutions here, which are going to be obtained by lessing 45 and 315 with 30 degrees on our left. Since if we move plus 30 to the right, you get negative. So 45 minus 30, the first solution is 15 degrees. Then 315 minus 30 degrees, you get 285. 285. So these are the solutions. Then you get yourself 5 marks. This is how you are supposed to do in order to solve this equation. Let us move on to question number 3. It reads, given that 1 minus ax to the power of n is approximately equal to 1 minus 15x plus 90 x squared plus bx cubed. Find the values of a, b, and n in 9 marks. Right, so in this question, you need to understand the formula of binomial expansion. 1 plus x to the power of n is equals to 1 plus nx plus n open bracket n minus 1 x squared over 2 factorial plus n open bracket n minus 1 n minus 2 x cubed over 3 factorial. So since the highest power is cubed, we are going to reach n minus 1, n minus 2, x cubed over 3 factorial. Right. So we are going to substitute minus ax on x, then we substitute n on n. I hope you are following. So let us get out the substitution process. You get 1, you get 1 plus n remains n, then on x you put minus ax plus n open bracket n minus 1, then you put minus ax, you raise it with power 2 to get x squared. 2 factorial means 2 times 1, so 2 times 1 is 2. We proceed. Plus n open bracket n minus 1, n minus 2, then on x you put minus ax, so you write minus ax to the power of 3. Then 3 factorial means 3 times 2 times 1. So 3 times 2, you get 6 times 1, it's 6. So you write it like this. Right. So I'm going to equate the coefficients. So let me start by simplifying this. You get 1. N times minus ax, you get minus a nx, something like this. Then you write plus. Remember, if you raise a negative number with an even power, the negative sign disappears. So negative ax squared, you get a squared, x squared, and the negative sign disappears. I hope you are following, class. So it means I'm going to write n open bracket n minus 1 a squared x squared. Then you divide this with 2. I hope you are following. But if you raise a negative number with an odd power, the negative signs remains. So it means negative a x raised to the power of 3, you get negative a cubed x cubed. So the negative sign remains. So if the negative sign remains, it means this plus is going to be multiplied by that negative sign to get a negative result. So n minus 1, n minus 2, a cubed, x cubed. So the negative times the positive, you get this negative. Then you divide everything with 6. Right. So at this stage, you are now equating the coefficients to formulate what you call the simultaneous equations. You can clearly notice that the coefficient x is minus 15. So I'm going to equate minus 15 with minus an. So you are saying minus an is good as minus 15. This becomes your first equation. I hope you are following. Then here, the coefficient of x squared, we have 90. Here you have n open bracket n minus 1 a squared over 2. Then equate this with 90 to get equation number 2. So you are simply saying 90 is the coefficient of x squared on the right side. Equate this 90 with the coefficient of x squared on the binomial expansion. I hope you are following. We are now equating the coefficient of x cubed. The coefficient of x cubed, here we have b. So I'm going to write b, right? Then equate this b with the coefficient of x cubed in the expanded expression, which is minus n minus 1, n minus 2, a cubed, all over to 6. So this one is the third one. Right. So we now want to solve the following simultaneous equations in order to find the values of a, b, and n. Right. So starting with the first equation, you can notice that the negative signs, they cancel off each other since they are appearing both sides. Meaning to say, you'll be left out with an is equals to 15, something like this. Then divide both sides by n to make a the subject. You get a is equals to 15 over n. I hope you are following, class. Right. So let us substitute 15 over n in the second equation on a. Right. You get n, open bracket, n minus 1. Then you put 15 over n on a, raise this by power 2, divide by 2, then equate this to 90. So if we cross multiply, you have n, open bracket, n minus 1. Then 15 over n squared is equals to 180. So I have multiplied both sides by 2 to get this 180. Multiplying here by 2, multiplying the right side by 2, 2 and 2, they cancel off each other. 90 times 2, you get this 180. I hope you are following, class. Right. So according to the laws of indices, the power 2 is going to affect both 15 and n. Meaning to say, 15 over n raised by power 2, you get 15 squared divided by n squared, which is good as 225 over n squared is equals to 180. I hope you are following. Let us cross multiply with n squared again. If I expand this bracket, you get n squared minus n, right? Here you are going to be left out with 225 is equals to 180 n squared, multiplying both sides with this n squared, right? Then 225 into 180, you get 0.8. So you now have n squared minus n is equals to 0.8 n squared, dividing both sides by 225, right? Let us collect the like terms. N squared, right, is going to be a like term with minus 0.8 n squared. If we move 0.8 n squared to the left, you get minus. Then you write minus n, equate this with 0. So n squared is good as 1 n squared. So 1 minus 0.8, you get 0.2 n squared minus n is equals to 0. Then factor out n as the highest common factor. You'll be left with 0.2 n minus 1 is equals to 0. I hope you are following. So you are saying either n is equals to 0 or 0.2 n minus 1 is equals to 0. So you are going for this one. Since if the power was 0, we are supposed to get 1 as the answer, right? But since we have several terms, it means the power is not 0. So it means the correct solution is going to come by solving the right side. So you get 0.2n is equals to 1. Then divide both sides by 0,2. 0,2 into 1, you get 5. So n is equals to 5. This is the value for n. Then to find the value for a, you go back to the first equation where we made a the subject of the formula. Insert 5 on n, you get a is equals to 15 over 5, meaning to say a is 3. I hope you are following. Then to find b, you substitute n is equals to 5 and a is equals to 3 in equation number 3. So if we substitute this, it means you get b is equals to minus, you put 5 on n, so you get minus 5. 5 minus 1. Then you write 5 minus 2. Then a, we calculated a as 3. So here you get 3 to the power of 3. Then you divide by 6. So if we punch this in our calculator, you get the value of b. So you are saying minus 5, open bracket. 5 minus 1 is 4. 5 minus 2 is 3. Then 3 to the power of 3. Then divide by 6. You get negative 270. So this is the final answer. I hope you are following. So in simple terms, we are saying a is 3. Then we are saying b is equals to negative 270. Then n is equals to 5. Then you get yourself the 9 marks. I hope you are following. So I want you to stay tuned as we move on to question number 4.